went with topics that related scale to decision making. So, so we've got some nice summary here. So linking data resolutions and error with model outcomes, sensitivity to upscaling, and semantics. We'll have a full list later if you want. Decision making is defining and linking the granularity of user outcomes and scale of interest informed by knowledge processes, spatial temporal interactions, possibly with Maxent. I think I'll just go through the separate points because that might make work better. And then I think one thing which is quite interesting is that to me it seems quite interesting, we discussed a bit about this idea of are there universal laws in scaling, which we disagree wildly on, and can we find them, how much do they exist, and can we then use them? And multi-scale models, so I guess issues around modeling across scales was another separate subject. And sorry, Lex, what did you mean by the top thing?
Well, it was that overarching one that Bill moved down into, I think, and it was essentially saying this, the scale of the decision, whether it's a landowner or a policymaker or a region, relates to the scale of the analysis and also then the scales of effect, whether they're trade-offs and synergies. And then that scale of decision is inherently linked to the scales of process, which in turn depend upon data and measurements, which will then actually identify scales of intervention and decision.
Right, was your 3 post-it note, which broke all the rules and hence couldn't be clustered. Yes, that's the one. Yeah. So what we did, we had a lot of trouble aggregating things into 2-year and longer time frames. So I think Lex, we've had a go, but we think for most of these things, you could answer most of these things quite quickly and badly, or you could answer them really well over 10 years. They're more long-term research things that aren't going to go away. So we had a lot of trouble grouping them into short, medium, and long-term things. So how do we link land cover, land use, thematic, and spatial resolution? What are the implications for decisions because of error accuracy issues in spatial data? And how do they affect model outcomes? How do we upscale from observations to landscapes if attributes are clustered and variable space may not be additive? Can data land cover, land use analysis and model semantics be linked? The answer is probably yes. Where are, in that linking through to decision making, where are the decision-making people in this, and what are the granularity of stakeholder questions and concerns? I think the answer to that we were given was lots of different scales depending on the question. Can we define scales of interest to DMers, decision makers, plots, field, farm, landscape, or county, etc.? And I think again, from our decision makers in the room, the answer was yes, probably all of the above. If I'm correct in that, Victoria? Emma? Is that roughly? They probably different scales would apply to different, decision making is a multi-scale process. So that's probably a short-term one because we kind of know the answer to the question, but that said, I guess longer term, it'll be an iterative process. Different kinds of policy will require different scales. So again, falling into all of them. Longer term, how can landscape decisions better take account into spatio-temporal interactions? So that's something that Lex flagged as being a particular challenge. That we know less about time than space, and spatio-temporal stuff gets tricky for the lack of data, but that probably, with the new data sets coming online, that'll probably get easier. Can Maxent be applied to assess national land use? What would be the constraints? So we've got this links back into general laws. So again, we were talking, how Roderick was talking about using something like Maxent. So can you, for example, say, we have our target for uptake of carbon via tree planting is XX gigatons or whatever it is. Can we achieve that? And what are the minimum level, what constraints do we need to put in, and what would be the changes to those constraints to achieve that target? Assuming we can come up with a model that uses the Maxent approach of just a few constraints to get as an aggregate number for land use that actually fits with reality. So that's using general laws or simple models, parsimonious models to make questions about land use. For data, how to aggregate spatial data without information loss. Are there limits to how far we can upscale data meaningfully? Again, that's probably, as the data quality improves, that answer will change. Are there methods for disaggregating and downscaling coarse spatial data? Yes. Is this more important for some variables than for others? Global versus local effects, and how do we deal with irregular sampling and data that's needed to cover different scales? So really all of these, I think, are ongoing questions that will probably continue to be ongoing questions as data evolves and questions evolve. For universal laws, they're in scale invariant laws to help identify and inform decisions. So we had a bit of a discussion around this. I think some of the 2-year ones we thought, actually, in terms of pattern analysis, if you use sort of some of the theory of fractals and that sort of stuff, we can identify where things are scale invariant and where they are not. And indeed, some of this work that Laura showed a couple of days ago is some early stuff along that. And there's a wider literature on this from a long time ago, from the 70s and 80s, where people looked at fractal patterns in landscapes. So I think we can probably do quite a bit more of that. Do larger scale socioeconomic patterns exist in land use that can be used to test socioeconomic models? Again, that's something we could probably get at reasonably quickly. Can periodicities in processes be explicitly linked to the time of observations and data? It's the sort of thing that Lex was talking about. We can probably do more of that now as more spatial data comes in, but it'll be a long-term thing. Can we infer the important scales in the system based on model fit? What top-down interventions would we need to achieve a desired overall outcome using max-end? I think we had that one before. Is there an a priori best way to cover space in spatial models? So that's almost philosophical. So do you use tessellations? Do you use hexagons? Which ones work best for different methods? But I think it's not something I've seen people work on, but quite an interesting one to think about. Can we link scale and movement? So James's idea, I think we put it in the longer term, not in the 2-year one. So I'm not sure James has quite finished it yet.
Peter doesn't.
What's that?
You understand it, but Peter doesn't.
Ooh, oh. Can we reframe our models to use scale-free or scale-invariant quantities? Longer term, are there emergent constraints for land use models? How much can we upscale empirical ABMs with sample data collected at much larger extents? And that's kind of getting at using the universal laws. So if there are universal laws, some simple things we can use in some places. Presumably one could use that information to then say, all right, in this kind of place, under these kind of conditions, we need this kind of ABM, which can ignore X, Y, and Z because the universal law applies. In this place, you need actually a much more complicated ABM. That's the dream. Does wrong inference die to scale nicely? Dude, does wrong inference due to scale mismatch go away when you model correct processes? Again, if you really understand what's going on in the system, you explicitly think about the scale, then you don't really need to worry about scale mismatches because it's just part of the model. And how should models accommodate the fact that different processes operate over different spatial scales is a longer-term, ongoing challenge. I think that's it. Well, the scaling, is there anyone else who has anything to add to that? Because I realized it was a fractious and really fun discussion.
Fractious?
A little bit.
That looked very coherent. It's almost
fractal.
Like you wrote those notes or Lex did before you looked at that stuff. Disappeared.
Can you fizzle through the whole
Sorry. Did we miss anything? Well, we probably did, but is there anything big I missed? Okay, great.
Can we go back? On the horse?
No, alright, so we're gonna.
I haven't got a presentation. I thought
No, it doesn't.
Oh, right.
So we're on the board over here, and we just kind of grouped our all the post-it notes into a few different categories. So I'll just kind of talk you through broad brush strokes. I've tried to write some notes here. So our first kind of set of things that come up about model coupling we think are to do with transparency, reproducibility, communication relating to the couple models. So our very first thing we've got here is really to do with kind of an open access revolution, I suppose, in these models, these model couplings, in that, you know, we're funded often by government money, by taxpayers' money, so actually these models should be made available for anybody to use, and there were some examples of models which are going down that route already and being developed in that way. I suppose sort of coupled to that, we have a set of things here which are about communication. So this is asking the question about what can we learn from other disciplines. So the work that has gone into thinking about how the IPCC communicates to the public, to governments, to make the case, you know, the sort of visuals, the way that they communicate things about uncertainty. I think there's examples from healthcare, the social sciences that are very good. Now actually what can we take from all of those to explain the results of our modelling? So this is kind of a near-term 2-year, a bit longer out. We've got questions about coupling models for fast run times as well, seem to be a big challenge. And going back almost to that open access idea, which we thought in the near term for new models which are being developed was very easy to do. We talked about some of the issues, and some of the issues have been raised about those existing models which are out there, which it's not easy to translate them into something that can be made open access and can be used by a much wider community. So thinking about how that might be achieved. So our next set of sort of post-it notes, next set of ideas which we've tried to bring together, all to do with a model coupling toolbox is how we've linked them together. So we have a set of questions in the near term here about common frameworks for data sharing, for transparency. So there was that discussion this morning about net CDF, and is there something parallel that could be used in this kind of landscape decisions program. A bit further on we have so there's actually a question in this pink one here: how do we overcome difficulties in coupling models? So I think there's questions there about how do we link models through, do we do it through standards? I think I had this kind of a bit of idealized view, you know, if Google can create all these clever tools to destroy the fabric of society, then I'm sure it can you know, think of ways to bring models together without having, in kind of an unstructured way maybe. I mean, that might be a bit further this direction, but you know, can it be done? Oh, we've got things like virtual labs here, understanding the difficulties in coupling, generating plug and play modules, I suppose, to build up these couple models as well. And then further out, we've got a set of questions here, which are, I think, a bit longer term, perhaps, in some of them. So we have questions there about, you know, can we couple very disparate types of models? So the example here is agent-based models and biophysical or economic models in a better way. And then right at the end here, again, we're going into sort of Star Trek territory, but this question about when we're coupling models and, you know, using emulators and things like that, are we going to reach a point in, say, 10 years time, 15 years time, when we don't need emulators? You know, our computer processing ability will pass the singularity, I think somebody said. Anyway, we'll see. So our next set of issues which have been raised over the month are to do with model coupling technicalities. I think so. Here we've got questions. So this is kind of the process of how we do it. So we've got questions about parallel and sequential processing when we link them as well. I can't read my writing. Oh right, okay. So here we've got a group of things which are all about understanding model assumptions, uncertainty, what are the kind of black boxes that are in those models, how can we get a handle on that and pick our, I suppose, our individual models that we're linking apart to try and understand whether those disparities between them are causing problems. So how do we overcome that? We move along to, I suppose, once we've understood some of that uncertainty in our sort of link models, we're then moving on there to, how do we propagate that uncertainty into the models? What impacts will that have? So when does the error propagation lead to convergence or divergence of results and things like that? And then further out, can we constrain the uncertainty in couple models? What are the techniques which we might use to think about doing that? Now, I missed one post-it. Well, I've not talked about any of them, but there's a very interesting post-it note here, which is kind of a near-term, I suppose, 2, 3, 4 year question, which is about using decision theory to quantify the value of information. So that was a question about when we, I suppose, what models do we want to link? Which bits that are within those models, do we need more data? Do we invest money in the data? Do we invest money in developing certain aspects of the model in a better way as well? And I think there's a whole set of techniques which can be used there to try and understand kind of investment in this, understanding the uncertainty and further research there. But that also links through to our final group here, which is benefits of model coupling. We seem to think was a theme that came out. So this is asking, again, what benefits do you get? Why do we want to couple the models? In what instances do we need to do it? Which models should be coupled and why? What are we gaining by doing that? And I think one of the research questions there, as we kind of move out in time, once we've got a handle on those sorts of questions, is to think about understanding how we can decouple models, I suppose, to understand what the individual ones are doing within them, because there was some talk about them, at the moment couple models can be so closely linked that it's very difficult to understand what the individual components are doing. So how do we decouple them and understand that, and are the processes to automatically do that as well? And that's a bit of a longer term, and that in a way links, these lines all link up to different things, right? So very good. That's linking into these ideas of having toolboxes or an open access and on all those sort of things to bring the work together. So I think that is that. Any questions? Oh no.
3 clusters over your head.
Sorry? Oh, well, these are these ones, yeah. Should I read them out? These were ones that we didn't know where to put, and we're not sure that they quite. So we've got does spatial autocorrelation serve as a spatial early warning signal for tipping points? I didn't think that was model coupling, but a very good question. Can we develop oh no, this one is model coupling. Okay, this one goes here, I think. Can we develop a couple model to look at the link from UK to global policy? So that was something that was talked about this morning as well, wasn't it? So I think the autocorrelation, I should probably go in the process modelling one, do you think? I think that's going to go there. Transparency. Can we do something similar to Lorentz equations for landscapes?
Yeah, that's.
Who wants that one?
Chris ones. I'll take those.
That was Chris. I think
Yeah.
Mark.
Okay.
He said no.
You could always make it crazy.
Come and get them.
You could make a 6-component model, right? One for one model and one for the other, and a coupling. So I think the answer is yes.
Okay. Right.
Question is still open.
Okay.
Okay.
Oh, To go to the toilet where it is.
No, check the computers for that. Yeah. Okay, since we're at the INI. So we had a wide-ranging discussion, which means we talked about an awful lot of things, not all of which are relevant, but a lot of them were. And we came up with a number of clusters, questions, and these are in a fairly arbitrary order. And for all of these, we had a fairly long discussion about timescales, in the sense of if we needed to, because DEFRA need to come together with a replacement for CAP, we probably could do something in the very short term, but it probably wouldn't be terribly good. But it would help. So for everything we do, there is something we could do in the short term, but we could do something much better in the medium to long term. So when I talk about timescales, I'm probably not going to talk much about the short term, because we can do that. We know that we can do something, and it would help, but it wouldn't solve the problem. So in terms of the short term, for this one, there are already some toolkits lying around. But if you want to build a proper framework for communicating uncertainty to decision makers, you probably don't just want to talk to the mathematicians and statisticians, you want to talk to the psychologists, you want to talk to the philosophers of science, and those people probably don't work that fast. Well, I don't work that fast. We're probably talking 5 to 10 years to come up with something that's really good. So we can do something on the shorter term. Okay, getting to probably the more mathematical ones. Model quality. How does the decision maker know that the model they've been given is appropriate and how good it is? And if they're given an ensemble of models, which ones are better at what and which ones are worse at what? And so we could build model metrics. We could look at Bayesian model averaging. We could look at verification, validation, uncertainty quantification, and we could probably do that on a sort of postdoc timescale. If you want a new full theory, particularly for the complexity of models we're talking about here, this is long term. But we could come up and say the short term we can do, we could come up with a metric tomorrow, but it wouldn't be the metric we'd come up after 5 years. If you notice, when you write on blackboard, you can't spell. Unintended consequences. Can we model unintended consequences and help to avoid them? And we had a nice discussion about this one, about actually modeling not for the best case, but actually modeling for the worst case in the unintended thing. So I'll think of an example. So you come up with a new common agricultural policy. What's the worst thing it could do to farmers?
rather than what's the best thing it could do for farmers, what's the worst thing that could happen. And we built on that, so you could do validation, verification on the wrong variable. We have a model of putting trees around. What does that do for flooding? And can we optimize that for flooding to make the flooding worse? How far is that from the optimum solution? Running the optimum solution on the wrong thing. No, can't read my writing for the next one.
Proper uncertain.
Sorry? Proper uncertain. My writing is very uncertain. I need my PhD student here. How do we make good decisions? And you notice that good is in inverted commas. And what is a good decision? How do we define what a good decision is? We rarely go back and look at counterfactuals. What other decisions could we have made? What would have happened? I notice I don't even talk about best decisions. I don't think there are any best decisions. In fact, we did discuss not putting not bad in here. How do you make not bad decisions? And maybe what we need to think about is how do we make auditable decisions that are justifiable decisions where we can say, this is why we made this decision, and that wasn't a stupid idea, was it? Again, that's not purely a mathematical question. That's probably also going to involve philosophy. We could do something on the short term, but again, for something really serious, you need sort of medium long term proposals. Tailoring, decision support models. So if we're going to use a model for decision support, we might want to make a different model to the model we make as academics to understand processes. It might be more focused. But there's another side to that which also came up, which was can't spell. Are we answering yesterday's question when we should be answering tomorrow's? Are we building models that are for yesterday's and today's questions when we really need models that are able to answer the question we don't even know what that question is yet, but it's going to pop up? Clearly there's a tension between these two. I think that's quite an interesting tension. I always like tensions between these things. Big catch-all models for this that are really expensive, hard to verify. These models would be fast. Decision makers could run them themselves. They could explore lots of things. We probably need a mixture of both in ensembles. That we have these to answer the question quickly, but we have these just to check that if another question pops up, we can in fact answer them. So I don't think they're not mutually exclusive. We need both. I think that's my summary of what we talked about. Well, it's a summary of what I remember we talked. We talked about lots and lots of things. Has anyone got any comments they want to make? Did I miss someone's favourite comment?
Sorry, could I?
Yeah.
Could I just ask about that last point? Do you mean within the same domain, I suppose? Answering tomorrow's question you know, because you're, I don't know, you're building a climate model now, and then all of a sudden everyone's interested in plastic pollution. Your climate model can't answer that.
No, I think we're in the landscape in the landscape domain. We may move from the question being how many trees should we plant to how do I get better biodiversity.
Right.
Now they're in the same domain. We're not moving from chemistry to physics, and you could imagine that there's a big model that would tell you the answer to both. Well, now let's just make it just forestry. So let's say that yesterday's question is how many trees should I plant, and today's question is which trees should I plant. And you could have a model that actually models the different sorts of trees, but because you've tailored it to this decision support thing, your model only says how many hectares of forestry should you plant. Does that answer that question?
Yeah, so it's kind of modularity, isn't it? You've
Yeah.
got a very big model, but you can
Yeah.
pull bits out.
Yeah, and I think that comes in the unintended consequences. If you don't model the unintended consequences, you can't say whether they're there. So models don't need to be too focused. Gosh, there's thousands of hands. No one else got questions. Jenny.
I think there was a little interesting subtopic. I don't know whether it was placed in the right place in the blackboard, but it was about a decision support tool can have built into it some concept that the decision you make now is not the only decision you're going to make. That was Elizabeth's point made. So it's actually well, where's Elizabeth?
Yeah,
She can say it better than me. It's kind of scheduling decisions, or like basically a framework for iterative decisions.
So it's taking account of the fact that you know that if you're faced with the same decision in the future, then you will apply at least as good techniques to use it in the to solve it in the future, and so therefore taking account of your future decision in your current decision.
So, does the sequential decision making cover that? Because you're taking stuff.
So I'm not sure what sequential decision making is. Danny,
I just made that up.
Equivalent. So.
But it's taking decisions. Yeah.
Yeah.
No, I don't think it's a thing.
Oh, isn't it? Okay.
It's just some words I've written here to say it. No, you can't go and buy books about it.
Yeah. So there was so related to that. There's the can we model when we expect to see the outcomes of a policy?
Yeah.
That could help you with this.
Yeah. And that's sort of, and again, I'm making this up, backwards decision making.
So we also had a cluster about studying how decisions are actually made, but we decided that was not really a maths cluster.
Oh, I missed that one. Sorry. No, that was on my notes.
It might have some elements of maths in it.
That was on my notes. That's the bit I probably couldn't read. How do real people make decisions? John?
Thinking about this bit about communication of uncertainty, I think I just think, what does it mean for and for who as well? So, even talk to policy people, or talk to the public, or at schools and things. That concept of uncertainty may mean very different things, or businesses. So maybe there's different types of definition within this. So risk and unknowns is a clear one to pick, and probabilities of things. But for some groups, there may be opportunities and potentials within this as well. So how you frame that communication is going to depend on your target audience.
Yes. EPSRC keep trying to get me to define uncertainty. I refuse to do it. Yeah, Nick.
If we should abandon the word uncertainty completely and replace it with certainty.
Ah.
Actually, what we're doing is communicating certainty. And it sounds much more positive if we turn around and say to people, we can tell you how certain we are of something rather than how uncertain we are of something.
Well, it would certainly make us sound better.
It's difficult to play with. Confidence?
Yeah, confidence. I would go with confidence, certainty, or confidence, or credibility of a decision, or something like that. I think it sounds much more positive and would probably be received in You probably need to tailor exactly which phrase you use for the audience that you're trying to communicate.
It is quite a well-documented problem with the work uncertainty that people instinctively think you don't know what to do.
Exactly.
What the hell are you being paid for? You're making a dichotomy between certain and uncertain.
Yeah.
It's a
But
really odd
it's
one.
so important that
I like confidence or credibility. Or,
But I think weather predictions are sensitized.
Oh no, you keep putting your hand up.
Yeah, and the decision support item there was also a notion that models need to be different. And there was a post-it which said, for what kind of decisions are models most useful? And that I think that rang a bell with DEFRA. And so on the short term, we identified to make a catalog of
You're quite right.
models, and that was useful just to have the landscape. That was in the decision support, actually. And that seemed to be very feasible on a 1-year time frame.
Yes, that is something that could be done in the short term.
Well, it was actually under the decision support one, but it isn't.
Well, it sort of fits with.
No, I have the blackboard in front of me.
No, it sort of fits with that as well. Where's the decision support one? I've lost that one.
Yeah, on the right. In the middle.
Oh yeah. You had it.
I was just going to say that getting to this, making tomorrow's decisions, that I guess there's an element of horizon scanning, the idea that you think about what kind of problems, scientific problems, are likely to come up, and then think about, again, dealing with these unintended consequences, having the option of having your model robust to those things, even if policymakers aren't asking for them, that even if they're things they might not be thinking about, but they might potentially be very important.
But I think policy sometimes moves faster than science. But the plastic one, I think, is the classic thing that suddenly everybody wanted to model plastics. And there were very few models of plastics around. You getting for a better shot?
I'm going to get a picture, yeah.
You won't be able to read my writing.
That's fine.
Paula.
I can show it to you and you can read it for me.
No, you show it to my PhD student.
I guess clarification on your term sequential decision making and backwards
Yeah.
decision making. So I don't know if that is that the same as all the work that's done on normative scenarios where you have a goal or a target and you either go forwards through a pathway through steps of actions that build strategies to make you meet the goal, or you backcast from that goal through a set of steps, and you normally then would model the backcasting because the whole.
That's the sort of idea, I think, that you know you're here, you want to get to there, but you're going to revisit the decision at these points. And therefore, the fact you know you're going to revisit the decision, and you're not making a decision and getting to there, you're going to make that decision there, and then you're going to go back, and you're going to go back.
Yeah, but there are different decisions and those different actions.
Yeah. Yes.
Because there is a whole literature out there in that to link in.
Right. I think that's what was meant. Elizabeth, is that the sort of thing you meant? That you're going to revisit this decision?
Going to revisit the decision, yes.
Yeah. And the fact you're going to revisit it changes what that decision might be.
Changes what your decision is initially. Certainly.
Yeah.
Yes. Yes. Because you know that you can adjust it.
Yeah, because you're going to tailor it as you go along.
Yes.
Yes. Any other questions? Bill.
Comment rather than a question.
That's allowed.
I think it's interesting to tell something about our psychology. That while there's give it up any hope of finding the best decision, there is still a mission to find the worst one. So
yes.
We can pessimize, but just optimize.
We're never going to act on that one. The whole point is you're not going to do that. But yes, it is an interesting question. That I wouldn't put up the finding the best decision. I can put up putting it in the worst case.
Is it worth saying just a few things about what we're going to do with all this information, given we're
yes.
into the business?
Are you going to tell me?
Hopefully while you and Coxie will say.
So, why are we collecting all this information?
question?
I was just about to answer it. And I was trying to think of the right words to answer it. So, as far as I understand it, there's very little money left in this current tranche of money. There's some fellowships that are going to come up, but most of the money's spent. But that doesn't mean that's the end of funding for landscape decision making. I should get Simon to do this. There are almost certainly going to be further tranches of money coming into this area. And if we can put together a case for long-term funding for mathematical ideas to improve decision making in this area, we can help NERC build that case to go to the government to get the money to fund this sort of activity. So we're going to write a roadmap, research agenda, whatever you insert your favorite science strategy term in there, to give to Heiko and to Simon, to give them ammunition to go and get more money that they can then give to us. So this is purely altruistic, trying to sort out how we can make better decisions, but it also could fund some interesting fun stuff for us to do, but we do have to justify it. They're not going to give it just because it's fun stuff for us to do. I've discovered that to my great loss of my career, that they rarely give you money to do fun stuff for you to do. But I think we're coming together with lots of interesting stuff. There is a Google Doc as well we set up for some of these longer term things. We can put stuff in there. If anyone wants access to that, just ask me. And it's going to help Peter with his talk tomorrow. Yeah, Kai.
I'm assuming, as we discussed already in the kickoff of this 1 month, that any kind of new pot of funding is 2 to 3 years into the future. So, for the sake of not meeting him in 2 years' time and doing exactly the same list on the board, what can we do in those 2 years? So we meet some of those things.
So, in a sense, that's what do we do after this program. So we had a meeting with David Abrahams at lunchtime about one of the things we talked about was follow-up meetings, and we will be writing a proposal for some follow-up activity at the INI, a 3 to 5 day conventional workshop in this room, or something a bit longer where we take over the whole place and have offices and are unstructured. It might be one or either of those or both. But the idea is to keep something going.
So the timing we thought about this workshop would be after the short grants have been completed, the smaller match grants, and we wash those up and then look forward and get an update on the larger grants. With a view to additional SPF funding, but also forthcoming calls that might be relevant, like the possible UK Forest Programme that kind of connects with it, so there's overlap. So there's a way that we might. The issue is the timing, so there might be a short workshop in order to be.
So that short workshop would probably be in November 2020, and a longer 2-week maybe thing would be July 2020. Sorry, we're 21. Oh gosh, let's skip that one. 2021. They're very booked up. The INI is full. But there are other places we could hold this, and I don't want to put words in Heiko's mouth, but he might want to say something about things he's planning that might fit into this sort of pattern.
I can do briefly. We will be hosting workshops from the program coordination team, to which of course you're all cordially invited. There are open community workshops where we're trying to engage a wide range of people with interest in landscape decisions, and I'm hoping we get a good take-up from this community as well as from the other work packages. First one, in fact, will focus on the new mathematics and new modeling activities in the program, so I think that could pick up some of the ideas here.
Right.
We also have, of course, existing funded research projects that continue beyond the funding of the Isaac Newton Institute program.
Yeah.
So it's also a possibility, you know, where the PIs across other projects see the value of particular ideas coming out of this activity, that they might be able to implement some of those as part of their work. So I think there's some merit in networking and coordinating what different elements of the program are doing. And we are, of course, also in continuous dialogue with the policymakers in DEFRA and the wider DEFRA family. So we're also quite happy to help in terms of bridging the gap to the decision makers and trying to pick up some of the ideas from this activity here with a view to translating that into policy relevant ideas that can be taken forward. I think it's also worth saying that there are all sorts of different funding mechanisms to take some of these ideas forward. It doesn't have to be only from this SPF funding. Particularly, I'm thinking about innovation funding. Some of the ideas I've been discussing here with various people probably could attract some innovation funding to set up a system or a tool or a modeling interface of some kind. You know, the virtual lab or some of these ideas could potentially be something that could be worked into one of those more applied grant applications. There's always the discovery science strand in NERC, although I realize it's quite competitive and hard to get, but not impossible. And of course, there's still the fellowship call coming out. In September, we are about to issue a pre-announcement of the Landscape Decisions Fellowships under this program, so watch this space in September. The proposal call will, if everything goes well, probably go out shortly after. And those fellowships would start probably in sort of middle of next year. That's the rough timing we have in mind. So that might actually map quite well onto the timescale you're talking about, Peter, with November 2020, July 2021, because some of the fellows might already be in place by then if all goes well.
I could ask, those fellowships are AHLC?
Sorry, no, those fellowships are Landscape Decision Program level. So they are under the NERC umbrella, if you like. They're not AHRC, but there is an AHRC community of PIs of the small AHRC grants, so the partnership grants and the follow-on fund grants that are currently being commissioned. When they will be announced, I'm not entirely sure, not on the top of my head, but there will be an additional a group of PIs, let's say, from those activities, who I'm sure can contribute a lot to the sort of human, socio-economic understanding of landscape decision processes. And that might also be an interesting activity in one of the subsequent workshops to discuss with the mathematicians and the AHRC PIs how those ideas can be incorporated into some of the modeling and decision-making support tools.
Danny.
So one of the things that we had a lot in the first workshop right at the start and then sort of through was that the program was supposed to bring people from mathematics and statistics who've never done anything in landscape or land stuff before get them interested in the problems and do them. The program finishes tomorrow. It's been very engaging for those of us who've never done any of this stuff. Is there a sense among how is that buy-in going to be retained? Will these workshops be enough, or I wonder if there was a plan for that? Because I mean, obviously, most people that were already thinking about these problems will carry on and maybe got something out of it. But a few of us are going home with an idea.
Yes. We would certainly like. We built a community. We'd like to keep that community and enlarge it. At the moment, those are the sort of things we're thinking about.
Would there be a way of recommending something to NERC? I guess I think that was my question.
Simon, we recommend.
I mean, from my perspective, what you've done here now, this is the start of whatever journey this is going to be. It started to bring two different communities together, something we try and do. It is difficult. It's always difficult to try and maintain that development and that piece going forward. But there are things up on the board there. There are the calls that are coming out, I was just referred to. Those fellowships are open across the remits of every single research council, so it's very wide. But Discovery Sciences, Heiko said, yeah, you can start. Just make a start here. The ideas that you've got in your head, put those down on papers. You can submit to the various calls and things that are going on. And I think, maybe hopefully Duncan and Linda will say tomorrow, this is a very important field. It's a very important area. And getting these disciplines together is a key way of actually answering these problems. So this isn't something that's going to go away, but you have to be understanding and savvy on how to sort of submit ideas and applications. The UKI world is a different world now than it was even 4 months ago. So, and there are funding opportunities there that weren't there 4 months ago, for example. It's using those things. So the opportunities are here now to continue this community, to continue this roadmap that we're setting there.
So the other thing we did discuss with the INI was that July 2021 meeting could write a proposal for a full 4 to 6 months INI program. Unfortunately, those take about 2 years, so we're talking 2023. Unfortunately, timescales are longer than I think we would all like for all these things. What we can do is to utilize some of the other resources we have at our disposal to keep people interested. And there are things like Royal Statistical Society environmental section meetings. I'm sure they'd love to have one on landscape decision making. We can keep people interested, keep meeting together in various things using fora like that, but we don't have any big sources. I don't have any big sources of money. I have any small sources of money. It'd be great if I did. No, I don't want it. I don't want to become a funding agency. Heike.
Bear in mind, if you add to that list the 4 workshops that the program will be running over the 4 years, then I think we do have a continuous stream of activities going on where people can carry on engaging.
Yeah. Okay.
Just to mention this, because I mean, some of you know about the Global Food Security Program. It doesn't have a mathematical context to it, but I'm involved in one of those projects. I forgot how many we have. I think about 14 or so. Somebody who knows can correct me, but the global food security projects, many of them go from landscape decisions all the way to consumer behavior, but they definitely, many of them have the component of landscape decisions at the beginning of them. So these are also programs that, projects that are relevant to those workshops.
Do you mean GCRF?
No, GCRF is something else, but I meant the Global Food Security Program that is also a joint research council program in here. So, and it's led by, so there is a coordination team in Oxford.
John England's team. Besides the GFS thing, there's not much more I can say, but do keep your eyes open, and there are systems level type opportunities that are going to be around the corner at some point that I think you are very well placed to apply into and use your skills and your discipline. So what you're doing now is very timely, not just for this SPF program, but for other big funding opportunities.
Okay, has anyone got anything else they want to say?